students, in differential calculus there are different concepts, different topics, different contents are there, but we are seeing all the content in different approaches, different formulas. But here first part is limits and second part is continuity and third part is differentiability. So, all these three put together only is a differential calculus. So, if you want to learn thoroughly, you should know all the three fundamentals, then only you can very compact with comfortable with differential calculus. Okay. Now, let us so you already learnt limits very clearly in all the concepts. Now, we are going to see a continuous. What is continuous? It is a continuous is a function it is. First of all, we are deriving continuous from the function. So, continuous, let me give a very good example to you, very simple way. So, you know coffee, when it was planted, you are getting that manual. So, that is the coffee is nothing but function first. The second time when it is making as a powder, it is nothing but the differentiability. If you are going to have a coffee, that is the second derivative. So, now the each part that countability is there, it is considered to be a function. The complete coffee, that manure, that is thing, what is the thing that is considered to be f of x. So, after that we are getting what is that? That coffee powder, that is nothing but f dash of x. After that we are getting a cup of coffee, that is f double dash of x. Remember that it is a very good example for your reference, simple example, just for so many things we can take it like this way. So, now let us see this one, it is a continuous function. Function is a continuous, each one is a function, remember that the first stage is continuous, and the continuous means it should be for closed as well it should be for open. A function mapping from a to b to real number is continuous on closed interval, and it is continuous on the open interval a comma b. Limit x tends to a, f of x is equal to limit f of a. Limit x tends to b upon minus f of x equal to f of b. F is continuous from the right at a, that means towards a, and f is continuous from the left at b, that means that is towards b. Towards means it is towards a here, this is towards b here, that means this is a plus and this is b minus, like this. A function is defined in 4 intervals here, one is 0, other one is x, next one is there is a function, and the last one is 4 minus x. But 4 different intervals are there, 4 different intervals. Remember that is in a real number system, minus infinity to plus infinity, the first part is 0, second part is between 1, and third part is 3, and the last part is infinity. Like that, there are 4 intervals. First one is minus infinity to 0, this function is 0 here, and second part is x here, and third part is that is minus x square plus 4x minus 2, and the last part is 4 minus x. Like this, now there are 4 intervals, and each part we are going to check whether it is a continuous or not. So, in this part, continuous at each point of x naught belonging to a comma b. That means how many intervals, how many functions do we have? 1, 2, 3, 4, or of which we have to check the first part 0, second part 1, and third part 3. Like that, I wish to check for the 3 parts. One is 0, second one is 1, and third one is 3. The previous problems are there. Before this, whatever the problem discussed, only one function and one interval, but in continuously it is given 4 types of functions with 3 intervals, each what we want to check. If we check, if we obtain the result, that means for lower as well upper, then it is okay. If not, it is discontinuous. Let us think over each part now. First part, let me take at x is equal to 0. How many intervals do we have? 4, of which how many points do we have? 3. So, 1, 2, 3, 4 intervals, of which the points are 1, 2 and 3. 0 is first point, and then next point is 1 and next checking point is 3 here. So, that means here towards this direction, towards this I wish to check for 0. So, let me have this. So, that means left limit of f of x, limit x tends to 0 minus here. So, let me take like this, that is f of x. Now, the corresponding function is what here? See, you look at this here, x less than 0, what is the function exists? 0. So, that means this is what the function exists, that means here only the function exists, that means limit x tends to 0 upon minus, that is nothing but 0, because x less than 0 only this is the function exists. So, answer is what? 0, that is 1, remember that. So, the same way the right limit of f of x, limit excuse me, the limit we have used LIM, limit x tends to here 0 plus f of x, that is right of f of x. Right of f of x, what function exists? X here. So, left means this is 0, that I have taken into consideration here, and here limit x tends to 0 upon plus, that function is x here. So, that means it is 0 here, that means it is 2. In the place of x, we have to substitute only 0 over here for x. So, that means it is 0. So, because in this x only I am just substituting the value, obviously it is 0. So, by seeing this from 1 and 2, what I am seeing, L of f of x is equal to R of f of x, that is left limit as well the right limit, that is limit x tends to 0 minus f of x is equal to limit x tends to 0 plus of f of x. Once again, so limit x tends to, in both cases this is true, therefore, f is continuous at x is equal to 0. So, the first case is defined here. For the first interval we checked. Let us see like this way as 1 as well 3. Next case is at x is equal to 3, at x is equal to 1. First case is x is equal to 0, we have taken and we have proved, and for the second case at x is equal to 1. So, let us take the function here L of f of x, limit x tends to 1 minus here. That means left 1 left of this and right of that. Left of this is f of x here. So, limit x tends to 1 minus and limit x tends to 1 minus, that is nothing but what function exists here, left, that is x here, that means it is nothing but 1, that is 3. The value when you are substituting in the place of x as 1, so it is 1 only, So, obviously, in the place of x we are substituting 1, so it is 1. Now, for r of f of x, limit x tends to 1 upon plus f of x equal to limit x tends to 1 plus, the right limit is what function exists, minus x square plus 4x minus 2. In this part, minus 1 square plus 4 into 1 minus 2, that is 1 only. So, here it is 4. 4 minus 3, it is 1. So, from 3 and 4 what we got? From 3 and 4 we could see, we can see that both limits are satisfied. Limit x tends to 1 minus f of x is equal to 1. Limit x tends to 1 plus f of x. Therefore, f is continuous at x is equal to 1. So, now we have taken each case. So, the interval is like this, the function is like that. So, 1, 2, 3, 4 intervals, of which we are taking 3 points, and first point we have finished, and second point we have taken into consideration, and third one at x is equal to 3. At x is equal to 3, this interval. So, towards left, then towards right. Towards left, if I take, this function is carrying over, and towards right this function will be taken into consideration, and towards left. So, we have to see this part. So, L of f of x, limit x tends to 3 minus here f of x. So, that means what function exists for this? X left of 3, that means this is the function exists, that is minus x square plus 4x minus 2 or exist. So, that means here I should just apply x tends to x upon x tends to 3 upon minus, that is minus x square plus 4x minus 2. In the place of x substitute 3, minus 3 square plus 4 into 3 minus 2. So, minus 9 plus 12 minus 2. So, 12 minus 11, which is nothing but 1, that means it is equal to 1. So, 12 minus 11, which is nothing but 5. Now, this is the one. Now, for r of f of x, limit x tends to 3 upon f of x here, limit x tends to 3 plus. Now, the right hand side function what exists? 4 minus x exists. So, 4 minus x. So, that means 4 minus 3, which is equal to 1, that means here also 1, that is 6. That means in this case it is we have got the result is 1 as codomain. For the first one, domain is x is equal to 0 and codomain also 0. So, that is the value we found out, that is equal to 0 here for that, and for that here the domain is 1 and codomain also 1 and it is continuous. And for the case at the interval at x is equal to 3, domain is 3, codomain is 1. So, that means we found out all the cases, we solved the result, and finally, we have arrived. Now, it is from 5 and 6. 5 and 6, we can see that we observe that limit x tends to 3 minus f of x equal to 1, limit x tends to 3 plus f of x. Therefore, in each case this is a continuous. Now, here at x is equal to 0, here f is continuous at x is equal to 3. So, concluding all the 3, so what is it? Therefore, f is continuous at x is equal to 0, 1 and 3. So, in that way this problem is completed and you could understand completely, even though the function with the different intervals given, how we can carry over the problems, how we can solve, how the domain and codomain will exist, how the problem will be, how the things will be done, you can do it. So, in all the three cases I have done, it is very simple. If you do this sum, you can do any kind of problem.